Okay, so I have finished compilation and upgrade the compiler since it's another day, right? Just upgrade the compiler, upgrade LLVM. I don't know whether the microphone is all set up right now because the microphone I buy the it's just using phone as microphone. It's just being very bad, you know. It's very bad the microphone. But I have tried to buy a new one right now. I have bought a new one, a very expensive one compared to this one. It just yeah the new microphone. It shouldn't have issues in next time I think. But let's just continue, okay? So after we finish the compilation with Ninja, right? You can deploy it again and Ninja it again. You can just Ninja install script, okay? Okay. Of course, it's the same thing as native compiler. Is that when we have when we build this thing, we build this. The table gen and a lot of things are not installed. Okay, the table gen are not installed. Because of that, we really need table gen because table gen is how the compiler can reproduce itself. If you don't have table gen, you cannot do further compilation on on LLVM on Windows anymore, right? You probably want to do Canadian compilation on Windows again, right? Because LLVM supports Windows better than building. Okay, does not act itself. It just the build is supporting more than GCC does. So we need to put this three table gen here. This LLVM strip unneeded. Or we can use x86-64. It must be the POSIX one, okay, not the Win32 one. Strip unneeded. It actually doesn't matter. So we need to strip all the tablegen.exe, okay? These three tablegen. And I'm going to copy this tablegen to the bin directory. To our it should be our install prefix, right? Install prefix, right? So we're gonna copy. No, it's install prefix. Wait. If it is install prefix, it shouldn't be here, right? It should be in the LLVM directory, right? It should not be in the GCC directory. Let's just go and see whether I did things wrong again. Oh no, this is GCC directory, right? They just they just compose the GCC with LLVM together, you know, which is not what we want. Although the installation doesn't affect anything, it's not quite good, right? So we need to actually change the install prefix to the install prefix what I care about, right? It should be here, right? It should be here. Then we're gonna reconfigure and build it again. What? It said it doesn't exist, right? Okay, we can just reconfigure and we build it again. We're gonna have a new installation with it. You don't even care if you're just doing things wrong. It doesn't matter because it doesn't override files, for example. And if we just recompile the file, it actually don't have much problems compared to other issues. We can call it again. We're probably gonna see more data. Okay, it's not upgrade either. Great, because LLVM upgrades very frequently compared to GCC. Then we install it again. Okay, right now it's correct. Then we go to we copy the tablegen. We copy all the tablegen to the tablegen.exe to install prefix bin, right? We copy all of them. Then we go here and see whether our installation finishes. LLVM tablegen. Oh, we also need to strip the table thing, right? Strip unneeded. You can either use LLVM strip or using x86-64 GW strip, okay? With all the table.exe. We strip all the binaries, and now we should be able to have the things we need here. Let's just go here. Let's go see LLC. So I go here, we go see LLVM. Now we have POSIX, right? Just entire LLVM, POSIX, whatever. Yeah, this is the entire torsion. Okay, now we have the torsion right now. But we cannot directly use it because we cross-compiled from the GCC, right? It's we need to put the GCC's combine the GCC's DLLs with this torsion together. We need to copy all the DLLs from our cross torsions to this directory. Okay, cross from the cross torsion to the directory here. Oh, here is the directory. Oh no, it's not here. It should be here, right? It should be here, right? We just put here. Put all the libs we installed yesterday. All the DLLs. We put all the DLLs here. Okay, just put all DLLs. Leave GCC, whatever. We just copy all of them. We don't care, right? We don't care all the DLLs, whatever. Just copy all the DLLs here. Okay, now it's finished. So now we have a torch, LLVM torsion. We can copy it and we can use it. However, there's something that's missed in this torsion. Okay, there's something very important that's missed in the torsion is that we cannot. When we compile things, we need to compile compiler RT. Okay, if we don't have compiler RT, it won't be able to compile things, right? So if you remember in the videos I made yesterday, we did install compiler RT, right? The compiler RT. So we can also just copy all the compiler RT into here, okay? Or we can just recompile it again. Doesn't matter. Okay, you can either recompile compiler RT or just you copy all the things here. Okay, all the things here. But we should just recompile compiler RT. Okay. Go compiler RT. This is native compiler. We go compiler RT. Recompile it again. What about the install prefix? Is that the same console we just put here? No, it's not the same console, right? So we go back here. Okay. Go back to. I think it should be in this console. No. Install prefix. Yeah, it's here. So we go back to here. And we start to recompile compiler RT, okay? LLVM. No, so when we recompile compiler RT, okay, I'll just show you again. So we better just use clan, not using GCC, okay? Using clan and LLD. The reason we want to use clan is that if we use clan, okay, we use clan to compile compiler RT. I don't know whether they're using thread. I think it doesn't need thread probably. Whatever, we can just have a try. So when you put cmake c flags, f use ld with LLD, okay. Cmake c xx flags, f use ld with LLD. Install prefix, right? Install prefix. Install prefix should be just our compiler RT, the location of our compiler RT. It should be install prefix lib, okay, lib plan 14. I think it should be here, right? It should just be here. Then we're gonna put is we put target C compiler target equals x86-64 Windows schedule or x86-64 whatever x86-64 Windows schedule. Okay. CMake Cicero, right? Cicero. So we need to put Cicero here. So let me first try the auto chance with not auto chance, just the Win32 version. I don't think it would compile. Okay, but we can have a try. Okay. Cross. Okay, it all failed. They all failed, right? Perform test. Oh, there's another thing we didn't put here. Well, what we're gonna do that, we're gonna put CMake system name Windows. Okay, CMake system name. We need to put it at Windows. And D Win32. D mean GW, okay? Yeah. If we can just avoid all the thing here, we better just avoid it, right? Avoid all the P thread thing, right? We don't want P threads. P threads. No std RTP thread. I don't think we actually need P threads in yeah, it doesn't need P threads. We can just use the Win32 one instead of using the POSIX one, right? It's gonna compile further. Oh, it cannot, right? It still needs thread here. It needs threads, right? So actually, so this here's the thing that the further doesn't work, right? But it's still required, right? Which is just ridiculous. Prefix. Let me see whether anything else we can do about here. Okay. Here we had it. Here we have it. Okay, all the Windows libs here. The ASAN, right? The address sanitizer, for example. We have the ASAN, UBSAN, whatever. x86-64. Yeah. Of course, if we want to eSign with Windows with the MSVC, we can just compile it on the Windows with CMake again. Okay, or we can use cross things here, but I suggest you do that on Windows directly, right? It's because it's easier. Okay. Now we have the torching here. There's some other libraries we can build it. Like we probably also want to compile Linux programs on Windows, right? Since I've already installed the Linux programs, right? So to do that, we can do something like this. We still put prefix, but we don't put our target. Okay, we don't put target. We don't put those things. Okay, which is things we're now using compiling things for Linux. Compile RT for Linux, right? Oh, it cannot show anything. It doesn't show fuse LD with LLD. We don't care, right? We just directly do this. I don't think it won't fail. I mean, if it failed again, the sysroot issue. Oh yeah, probably we set sysroot. We shouldn't set any sysroot here, right? There's no sysroot. Okay, no sysroot because we shouldn't set any sysroot. Okay. Then we can use fuse LD equals LLD. Then you can compile the things for Linux because, right? It should compile the things for Linux right now. Linux, yeah. You install libcxx? I don't know. It looks like it's installing libcxx right now. Huh? It looks as if it's really doing this. Yeah. Whatever. We just install here. Okay. If it asks us to require install, we just install here. libcxx. Yeah, okay. This install libcxx with it. Okay. LLVM. Install strip. Okay, install strip again. Now install the libcxx here. Okay, libcxx. Okay. We can also just compile, for example, with ARM. ARM also works. What we're gonna do is we're gonna put target and CMake sysroot here. Target. Which is ARC64 Linux kernel we just put yesterday. Now, if you find that it doesn't work, for example, it cannot produce binary, something like that, you can probably. Okay, it assumes it's isolated 32. So here's the thing: if it's gonna assume we are using x86, which is incorrect. Let me think about it. Compile RT. We can just go here and cross compile RT. Go here and see what LLVM says. Yeah, it says here. It should tell us how to just get triplet, right? Compiler RT. No. It shouldn't be here. Architecture. No. So whatever, bare metal build, whatever. Actually something which is quite interesting is that in the WASI SDK, they actually told us how to correctly do this. Okay, so you might ask how the WASM works here. WASM is actually using the torching, right? Using the torching, using the building the compiler RT with compiler works to enable the extra checks. Okay, that's how it works. Compiler RT. No, not bare metal. Okay. Compiler RT OS directory. Yes. When we have any issues, we just can go back to see the SDK what they are doing, and we can just copy things from them. It should be something like arc, right? It should be. I'm telling you that it's not x66. It's right. It should not be x86. It should be something else, right? And x86 64. Default triplet only, no. FPIC, no. Okay, everything is now. Let me think. No, I don't think it's a thing here. Let's just go to LLVM project to see the CMake list, what they are doing here. You can see even we are using clan, we still need to compile GCC, right? You can't tell me that you don't have GCC, you're gonna just use a clan. That's not the world works, okay? Even you're arguing some other platforms, they're actually just emulating what GCC is doing. You're still actually using GCC, right? So, architecture. Yeah, default triplet target, arc. So, right, it should be here, ER64. I don't know why it's called ARM3264 or ARC64. I'm just calling it ARC64, okay? No, it's not i312, right? It's not i32, right? It's not i32. Right, it's not x62, right? So, go built-in, so see what's wrong here. Because by default, it will just assume things with the native torsion, which is not what we want, right? It's not what we are trying to do. Architecture. ARC64 arc. Just called arc? You're telling me it just called arcs, right? Probably it should be arc. Let's just have a try. Okay. We better just delete things before. Okay. So it's quite funny, right? I don't remember it's a case, right? In the built-in supported arc. Yeah, it should be default or default triplet. Probably gonna solve problems here, right? It should be probably default triplet. Anything else? Default arc.哈瓦桑，哼，哈瓦桑。Yeah, AX64 right now. Right, it shows us it's AX64 default target. Yeah, it should be AX64. Right? ASAN. Oh, it says it V8. It's still actually 64. Okay, let's just ignore that part. I can do it later. So, yeah, that's basically how the things work. You need to build a compiler RT, then to work, make it cross-compile on another machine. Probably I think probably you can use libgcc actually. Probably, okay. But let's just go to C here. So we go back to Trojans. Go LLVM. Okay, we're gonna copy the file here. Right? Probably I should just target the entire thing here. Actually, quite opposite. We shouldn't copy here because it's not saying it's always running here, right? Okay. Here is our LLVM. Actually, I'm not suggesting you to delete the old versions because probably you have compiler art you can copy from. Okay, but here we're gonna just do things here. Oh, it's 500 megabytes. Copy here. 500 megabytes. Okay. LLVM. No, we don't have LLVM here. Okay, good. So we don't have more issues with LLVM. We can see we still have issues, right? Because, like I said before, I did not put things here. Oh, please don't. It's not that one. It's this one. We're gonna compile it. We're gonna unzip it. All right. So now we have the LLVM that is installed here. We just put that into share libraries, right? Just put that in the environmental variable, and we now have the torches. Please be careful, very careful. Okay, be very careful with it. Don't put that before your GCC because they don't use the same libs as CDC++, right? Then you get ABI issues with your applications. Put it here, we can just try to compile programs, okay? I'm going to show just 2 examples. I'm not going to show more. And you can just continue to do that by using this toolchain to compile RT with MSVC. Okay, probably going to show here is how to compile MSVC programs. You can compile hello world. They don't have C++23, right? They only have this thing. I have to use LD for LD. Okay, see what the client version is, right? It's client today. It's this version. Yeah. Hello world. Yeah. So it's using the x86-64 Windows GNU, right? But actually, we can also use MSVC's thing here. So the thing is done by using here. Go here. So we can go client plus hello world. Hello world. We need to put .exe here. Okay. Okay, I think actually so show things here. With the course construct upstream from syscall things. So we will be able to know what's our setting right now. Remember, when you compile it with MSVC, you need to put .exe here. Still all fast, but no S. Okay. It should be. We cannot put S. S is useless. But with MSVC, we need to do DLL equals 1. L MSVC RT. Also, this is a library application requires anti-DLL, so we also need anti-DLL just like we did before. So now we compile a program that using the MSVC standard library. Okay, this is MSVC. Oh, not GCC. Okay, we did not put target. We need to put target here. x86-64 Windows MSVC. Okay. Okay, we can also cross compile Linux program by selecting target. I'm going to show it later. I'm going to show it again. So that's about the video. I hope you enjoyed. Thank you for watching the video.